This is our startup for week number 6. Number 1, it says solve the system by graphing. Now understand, when you're given a system to graph, all it is 2 problems put into one. That's all you have to, or that's the way you have to approach it and have to treat it. If you're given an equation, graph it however you want to. Whatever method that you want to graph it in, that's the way you need to graph it. So I'm going to do these equations in 2 different ways. If I'm looking at the first equation, I'm going to solve that equation for y. So if I have negative 3x minus y is equal to a negative 10, I'm going to move the 3x or negative 3x over so it becomes positive. And then I'm going to divide everything through by negative 1 to get y by itself. All it does is changes the signs. So that gives me y equals a negative 3x plus 10. So therefore, my slope equals negative 3. My y-intercept equals 10 for that one equation. So on my graph, I'm going to go up 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. I'm going to put a point. And from that point, I am going to plot a slope of negative 3. So that means I go down 3 and over 1. Down 3 over 1. And I continue to do that. There's several points. You only have to have the one. I just wanted to keep doing that until you'd see where it would cross the x-axis. So I draw a line through it the best way you can. So there's the equation of the first line. Now the second line, I'm going to graph it differently. Both equations were in standard form, but this one I'm going to plot by my intercepts. Remember, to plot by intercepts, we can either use the cover-up method or what we just say, plug in 0 in for the other one. So if I covered up x and I solved for y, y would equal negative 2. So that means I'm going to put a point at negative 2 on the y-axis. Also, solving the other one, I'm going to cover up y, and I'm going to solve that equation for x. So x would equal 2. Then I'm going to plot that point. So then I have a line that's going to go between those 2 points. So now, as we graph both lines, we see that they intersect. Now, when they intersect at a point, we want to try and label that point. And as we see here, these 2 points cross each other, or these two lines cross each other at 3, 1. So therefore, the solution by solving this system by graphing is at 3, 1. So number 2, it's a little different. Number 2 and 3 is still solving systems, except 1 is asking us to solve by substitution. Number 3 is asking us to solve by elimination. Now, with substitution, our goal, remember, is to get the equations equal to the same value, or having one equation solved for either x or y, so I can substitute in. Notice if we look at the first equation, 5x minus y equals 5, y has a coefficient of negative 1. So it would be very easy to solve that equation for y. In order to solve that equation for y, I would have 5x minus y equals 5. I'm going to, in this case, I'm just going to add the y. So it gives me 5x equals 5 plus y. And then I'm going to subtract the 5 from both sides. So 5x minus 5 equals y. So I've solved that equation for y. It's essentially slope-intercept form. It's just reversed. And we can flip it as long as things are equal to each other, we can flip it. So now, what does that mean? If I'm solving by substitution, since y is equal to 5x minus 5, in my second equation, wherever there is a y, I am going to substitute 5x minus 5. So I'm going to take that second equation of 5x minus 3y, but y we found is equal to 5x minus 5 equals 15. So all I'm doing is rewriting this problem for what I have solved for y in the other equation. I can substitute that in. So now all I have to do is solve this equation for x. I distribute. So it gives me 5x minus 15x plus 15 equals 15. Combine your like terms. Negative 10x plus 15 equals 15. Now if I take this 15 across, it changes signs. So it becomes a negative 15. So I have negative 10x equals 15 minus 15. But 15 minus 15 is 0. And I think a lot of you lose this right there where you say negative 10x equals 0. You're still dividing. You're still solving. And understand 0 divided by any number is still 0. So x equals 0. But we're not finished. In order to solve a system, you have to have both an x and a y value. I know what x is. So I'm going to go to this equation here. And since x was 0, I'm going to plug that back in. I'm going to substitute that in to solve for y. So y equals 5x, or x is 0, minus 5. So finishing the problem, I'm going to just work it out. 5 times 0 is 0. So 0 minus 5 gives us negative 5. Now, the solution to any system is always an ordered pair. So my answer for number 2 would be 0, comma, negative 5. That is my answer, my solution. Now, a way to check that, you could plug it back into both equations and it would have to satisfy both equations and make it true to know that you made everything, all your computations, everything was correct. All right, let's look at number 3. Number 3 says use elimination. Whenever we're using elimination, we want to eliminate a variable, either x or y. In any case, it does not matter which one we eliminate, because then we'll solve for the one we have, and then we'll plug that back in. So now, since y have opposite signs, I have a positive and a negative, I'm going to choose to eliminate my y variable. And the way that I'm going to do that is I'm going to multiply each equation by the other coefficient. And what I mean by, since this equation has a 3, I'm going to multiply the bottom equation by 3. And since the second equation has a 2, I'm going to multiply the top equation by 2. And when I multiply everything in that equation. So it's essentially I'm distributing. I'm going to say 2 times 5x, which is 10x. 2 times 3y, which gives me 6y. And 2 times negative 6 gives me negative 12. And I'm going to do the same thing for the second equation. I'm going to say 3 times 3x, which is 9x. I'm going to get 3 times negative 2y, which is negative 6y. And I'm going to say 3 times 4, which is 12. Now, by elimination, I can now combine these two equations. I'm essentially adding. And notice if I add 10x plus 9x, I get 19x. And if I add 6y plus a negative 6y, notice that they are eliminated. They become 0y. So they're eliminated. And then negative 12 plus 12 gives me 0 as well. So I'm left with, essentially, 19x equals 0. Now solve that equation for x. I'm going to divide both sides by 19, which means that x equals 0. And by getting 0 as x, I now have to solve for y. So I have a choice here. I can either plug it into my first equation or my second equation and solve for x. I'm going to go with the second one. I'm going to say 3 times x, and x is equal to 0. Minus 2y equals 4. Solve. 3 times 0 is x, or 3 times 0 is 0. So I'm left with negative 2y equals 4. To solve for y, I will divide, so y equals negative 2. Once again, my solution is always an ordered pair, so it's 0, negative 2 is my solution. Moving to number 4. We want to solve this system of inequalities by graphing.
I'm guessing this section's on graphs.
Chapter 2 is on systems, different types of systems. Now, once again, what have we talked about systems? A system is just 2 or 3 or 4. We're dealing with 2 inequalities or 2 equations on the same graph or in the same problem. So we're going to treat both of these. We're going to independently as if we did number 1. The only difference is we have a shading because they're inequalities. So with the first equation, y is less than or equal to negative 3x minus 1. I've got to find my slope. So the first equation, my slope equals negative 3 because y is by itself. Y-intercept equals negative 1. So at negative 1, I'm going to put a point. Now slope is rise over run, so I'm going to go down 3 and over 1. I only have to have 2 points to draw a line. So I'm going to plot that. So there's the equation of that line. Now, but it's an inequality, and that's the reason why I made it as a solid line, because it's got that equal to portion underneath it. I've got to shade a region. Now, 0, 0 looks as if it could be on that graph. So I'm not going to choose 0, 0. I'm going to choose another point. I want to choose 1, 1. Here's that point, 1, 1. So if I plug in 1, 1, is 1 less than or equal to negative 3 times 1 minus 1. 1 less than or equal to negative 3 minus 1. 1 less than or equal to negative 4. If that is true, I'm going to shade in the region of 1, 1. If it is false, I'm going to shade in the other region. 1 is not less than or equal to negative 4. That is false. So that means that I need to shade this side over here. On the opposite side of where my test point is. My test point is at 1, 1. So I'm going to shade the opposite region or the opposite side. All right, my next equation. Let's change color so we can see the differences. The second equation, my slope equals 3. My y-intercept, which is my b, equals negative 2. So at negative 2, I'm going to have a point on my y-intercept. Now my slope is 3. That means I got to go up 1, 2, 3 units, and I'm going to run. Up 1, 2, 3, and run. And so then I will plot that line. Now, since it is just an inequality, greater than, it will be a broken or dashed line. Such as that. So now I have to once again pick a test point. 0, 0 looks close. 1, 1 has already been used. So if I choose, I'm going to choose this point right here. That is 5, 0 as my test point. So as I plug that in, 0 greater than 3 times 5 minus 2. Is 0 greater than 13? That is false. So that means that I have to shade everything on this side of my green line. So now, if I go back and extend this line, so we can see this a little bit more, I'm going to extend this red line as it goes up. We shade, with a system of inequalities, we shade the common region. The region that it contains both. So it is all of this to this red line, and then once we get to that green line, we have to start following it. So all of this region to the left is what we call our feasible region.
Basically, we're just coloring.
We are coloring. All right, moving to number 5. Once again, solving a system of inequalities. We're going to graph just like normal. Both of them are in y-intercept or slope-intercept form. So my slope, oops, can't use the highlighter. My slope equals -3. My y-intercept equals -4. So at -4, I'm going to put a point. My slope of -3, down 3 over 1. It has the equal to portion. So that means it will be a solid line. So my slope for this one equals -3. My y-intercept equals -4. Now I've got a shade. My test point of 0, 0 would work. Whoops, I erased. My test point of 0, 0 would work for this one. Here's where it lies. If I plug that in, 0 greater than or equal to -3 times 0 minus 4. 0 greater than or equal to -4, because those will cancel. That is true. So that means everything on this side of my graph will be shaded for that inequality. Changing colors, let's go to the second equation, or inequality. I have a slope of 1/3. I have a y-intercept of 1. So y-intercept at 1, slope of 1/3, it means I go up 1 and over 3. It has the equal to portion underneath it. So therefore, it will be a solid line. Choosing a test point, once again, 0, 0 will work. 0 is less than or equal to 1/3 times 0 plus 1. 0 less than or equal to, that cancels 1. That is true. So everywhere my test point lies, in this case, is on the lower part. Now, by me just drawing lines, notice the crosshatch. Where the lines cross each other will be my feasible region, and so it'll be all of this down here. That is my actual solution.
I thought it would go up if it was true.
And number 6. Still solving or graphing inequalities. First equation, y is, or inequality of y is greater than or equal to 3x. There is no y-intercept. My slope equals 3. Y-intercept equals 0. As I say, there's no intercept in my equation. So that means my intercept is at 0, 0. Then I have a slope of 3. Up 3 over 1. If you have to, keep plotting graphs. This is an equal to, so it will be a solid line. Now, my intercept is at 0, so that means definitely I cannot use 0, 0 as a test point. I'm going to choose 5, 0 as a test point. 5, 0 as a test point. So if 0 greater than or equal to 3 times 5, that 0 is greater than or equal to 15. That is a no-no. That's false. So that means I'm going to shade on the opposite side of my test point. Everything over here. Now for my second equation, it is, paying attention, absolute value. So the way that we graph an absolute value, notice that it is in the form of x minus h plus k. So my h equals -2. My k equals -3. So that means that -2, -3, which would be right here, is my vertex. And if we need to, we can plot some or plug in some points. At -2, we have -3. What if we plugged in -4? Let's plug in 0. Where are my points? -4, -4. If we plug it in for x, gives us absolute value, was it -5? If we plug in 0, ooh, that's wrong, sorry. Gives me -1. If I plug in 0, I get -1, so that gives me the other points. So at -4, I'm at -1. At 0, I'm at -1. And it is not equal to. So this is a dashed line, broken line for this graph, going up through here and going up through here. So there's the graph of that absolute value. It is a broken line. I still have to find a test point. I'm going to use the same test point of 5, 0. So going back to my original, 0 greater than 5 plus 2, absolute value minus 3. 7 minus 3 is 4. Is 0 greater than 4? That is a big false. So that means I'm going to have to shade everything inside my inequality. So therefore my solution comes down through here and then follows this green line. That would be my cross-hatched area, my feasible region. And that is your startup for week number 6.